Good afternoon, everyone. I'm audible. Please confirm over the chat window and also enable the mic for you.
Yes, sir. Good afternoon. You are audible.
Thank you so much. I appreciate Rohit. Yeah, so let's get started without wasting much time. I'm going to share my screen. All right. So welcome you all to the new semester. Exciting journey ahead. Okay, I shared my screen. I recorded also. Fine. Yeah. So your model, which will be learning together, is web technologies. Okay, this is what the course handout. I am just going through it. I'm not sure whether you have received this course handout. Okay, so that's the reason why I'm gonna discuss about the course handout first, and then later on we'll go to the context session one discussion today. I think we have a good number. Let's get started. First thing, course handout. Okay. Web technology is the module name. Uh, these are the course objective, what we're gonna learn over here. Learn client side and server side technology associated component involved at both client and server side. Okay. So at both the side, what are the various component and technologies? That's what we're gonna learn. Okay. We're also gonna learn, the structure of a web page and how to design the same using HTML, CSS, and able to understand client script and also server script, web page, client script using web JavaScript. Okay. Uh, and we also want to learn, understand three-tier client-server architecture, how to develop simple web application with a web interface to accept input and process them accordingly. Okay. And also gonna learn working of a web server, corresponding administration for publishing, managing a web application written in PHP. So we're gonna learn four technology over here. Okay, so this is uh, sorry about this. Yeah. So we're gonna start with HTML. Okay. CSS, JavaScript, and PHP. Okay. Uh, so HTML more towards design, and let me just see this. Yeah. So for the client side, we're gonna learn HTML, CSS, and JavaScript. For web server side, PHP. Okay. That's what gonna be journey. We're gonna see that how to take this ahead. Okay. So this is your course agenda. Uh, two textbooks have been prescribed over here. Uh, this one textbooks, two references books are there. One is Robert V. Sebesta Programming World Wide Web, 7th edition, and there are two more references. By Paul and Harvey. Few web references over the net. Mozilla Doc and developer Mozilla org. So we're gonna see and some doc for so for all this HTML, CSS, JavaScript, their document we're gonna refer. Okay. These are the module structure. The first module talks about introduction to web technology. Second module about the HTML. The third module about CSS. Okay. Fourth about the JavaScript. Fourth, fifth about the JavaScript. Six about the XML, extensible markup language. And seven about what are the web server. And we'll do a programming on web server, server side scripting, which is using PHP. Okay. Once this entire, the module is over, what are the learning outcome we'll be getting? So all of us, demonstrate how to develop a simple web pages using HTML, CSS, and JavaScript to accept user input and validate them at client side using JavaScript. That will be able to do it. Okay. So just 1 minute. Yeah. So that is for a client side. Uh, we'll be also able to develop simple web application using PHP to receive input from client side and able to fetch information from backend. Okay, backend, so database. PHP also help us to do the logic processing, application logic processing. We'll talk about it in more depth as and when topic comes. We also are able to understand how to set up web servers, publish web application manage. We're gonna deploy a web application onto a web server, and also understand server side logs and how to debug simple web application, rectify the problem in them. So this is about the overall learning outcomes. As far as context session plan is concerned, there are going to be a 16 context session. Yeah. And in context session 1, we're going to understand more about the web technologies. Okay. What is Internet, World Wide Web, web servers, browser, protocol, and languages. So this language is not going to see, but yeah. In context session 2 and 3, we'll start with the HTML and XHTML. HTML5. We will concentrating on HTML5. We're gonna see some elements, list, table, forms. Basically for a basic web application design. For more on gonna talk about the CSS cascading style sheet. So we're gonna see a list, text alignment, color, box model, span, conflict resolution. Okay. Fifth, sixth, and seven talk about the JavaScripts. Okay, and eight will be a recap session. 9, we're going to talk about JavaScript document object model. So basically in 8, we're going to see a basic programming concept of JavaScript. And in 9, we're going to see a document object model. Okay. 10, we'll talk about XML. 11, 12, talk about what are the web server in depth. Okay. There are many actually. This is talking about only MIS. I mean, Internet Information Service and Apache. 13, 14, 15, and in fact 16, we'll do a PHP programming. Okay. So in all, yeah, that's what it is. You also need to perform certain assignment and develop a mini case study using the lab setup provided to you. We're gonna share that. Okay, that we're gonna be there, and this is the lab we're gonna do. Design web page using HTML. Okay, to explore commonly used standard markup language. Apply CSS. Okay, exercise JavaScript. Use DOM, document object model concept. Of JavaScript. Okay, and yeah, then PHP to process the input. As of now, I don't want to talk about this because these are still into a discussion stage. That how many quizzes will be there, whether there'll be a daily quiz or not. I'm sorry, weekly quiz or not. Okay, so you will have quiz 1 and quiz 2 for 5 marks each. That is sure. Assignment will be there for 15 marks, but still, we are discussing whether there'll be weekly quiz or not. So please allow me a week's time. We're gonna come back next week and confirm this. Okay. Yeah, that's about the course handout. I'm not sure whether you received or not. Have you received the course handout? I think no. What's your response? Have you received the course handout, everyone? Please confirm. Hello. Am I audible? Hello. Okay. So have you
Yes, sir,
received the
I'm audible.
yeah? Have you received the course handout? That's my question. Course handout means syllabus. the which I was just sharing. This one. If not, you will receive it. Gonna receive it soon. Okay. We are just setting up the things, so excuse for a week. Okay, that's great. Let's okay. As far as I am concerned, I am Satish. Okay. Uh, Education, BTech, Computer, MBA, in IT, SPGen. I have total 25 years of experience. Started as a developer, then now working as a client engagement manager, who moreover delivery manager. Okay, so I bring a business, and if my sales team bring a business, then I make sure that they complete those project on time or before time. Uh, Bits is concerned, I am associated with Bits since 2007 as a you know uh, you can say as a knowledge anchor. Okay, so I like sharing the knowledge, learning more and more on weekend, Saturday and Sunday. Okay, so yeah, that's all. Thank you so much. Let me go and start it. I'll just see a last final count is 48. That's great. Okay, so let's go ahead and launch this one. So I already started the recording. It seems yes, it is. So yeah, we are here. Recording is already started. All right. So few point as usual. You need to keep on responding. Whenever we take out your name. Okay. So this is a few instructions. Very important. But so context session one. Okay. So here we're gonna talk about the internet and www World Wide Web. Okay, and this three important concept. But our more time will be invested doing programming using HTML, CSS, JavaScript, and PHP. That's all the overall and learning of it. Okay. Since we're gonna develop a web application, so we need to understand the how this entire the web works. If not in depth, that's okay. The outer knowledge is enough because our more main into learning these four skills: HTML, CSS, JavaScript, and even XML also will be learning. That's also very important. And the what is called PHP. Okay. So about the internet, the very good history about it. Is that uh, it was basically the idea was not to basically help the end user. Okay, so there were an issue in terms of communication uh, in the defense system, okay, of the USA. Okay, so they decide that what are the best way of communicating between the two machine, or communication should be globally anywhere at any time and so on. So that was basically there the measure objective. Okay, so they wanted to communicate anywhere, anytime. Okay, and on any platform. Okay, so that was their main objective. What they were not able to achieve because of their existing system. Okay, so any idea how they used to communicate before internet between two machine? Anyone? How the communication used to happen before internet between two machine? Any thought, anyone? And honestly, I'm not here to basically read presentation. Okay, it may be just for this session. Next session onwards, we'll start the full-fledged programming. Okay. So, and have you ever thought about that? How two machines were communicating? Before the internet era. Anyone? Okay. So, Bishwesh says it's available in Takshila. Great. Thanks, Bishwesh. So, how machine were communicating before the before internet concept has started? Any thought around it? So have you ever, thought? I think like your generation, has got n number of things, inbuilt, like on the, plate, and that is where, you are so basically you are all of you are lucky actually. You know, you got such a complex technology has been given in a very, flexible way. So that's the, thing about it. Okay. So, what was the mode of communication before internet? Okay, so if not, no problem. That is not, the discussion point. But I'll show you. See, that's what I had searched. So this is the, before internet, computers, communicated primarily through a direct connection. Look at here. So before the internet, computers communicated primarily through direct connection. Very, troublesome. In fact, and if you want to see a more explanation, I'll show you this. So what was it? So have a look at it. So they were direct connection or dial up using modem or phone lines. Okay. So before the internet, computers communicated primarily through direct connection or dial up using modem or phone lines, often with the help of networks like ARPANET or Bulletin Board System BBS. You should, not have a thorough knowledge about it, but just, try to, heard this somewhere, try to just at least, get this thing into your, like mind system saying, yeah, I heard somewhere this term like what's a ARPANET, okay, or what's a BBS, very, important concept about it. Okay. So that's what it is. So computer could be physically connected using serial cable for data transfer, or they could communicate over phone line using modems, which, converted digital signal into analog signal that could travel over telephone lines. Okay, that was the here, a little breakdown. And if I can go and just, so dial-up connection. In this method, a computer would dial up a phone number to connect to another computer, either directly to a system like BBS. So this was essentially like, using telephone network to create a temporary network connection. That was so, though it was that point of time, it was, amazing actually. Okay. And they're talking about the ARPANET. See what it is. So it was Advanced Research Project Agency Network, ARPANET, created in late 1916, is considered the precursor to the modern internet and pioneered, packet switching technology to enable communication between different computers. Okay. And then what about the, bulletin board system? So BBS were, early form of online forum of communities where user could connect to a central computer via modem to exchange this. Okay. So these are the, few, terms. Just be aware, ARPANET, BBS. Okay. Now, how the sharing of information used to happen? So computer were used to share research data, technical information, and other important files through a direct connection phone line or early network. Okay. In fact, they could have used a offline mechanism also. So what they used to do, they should take a data into a, let's say a floppy disk, okay, or in some storage device or magnetic disk, you say, and then, from one place to other, they should travel. That also has been done. And, then put the content or program into another machine, do a communication, perform a task, and again get back that output into a magnetic disk, and again, store into a disk. So it's kind of offline communication also. Let me, uh, just a minute. Yeah. So email, text message. I am before email, people used to variety of ways to send message across network. BBS allowed people to leave messaging on a computer. Just a minute. Uh, Sorry. Yeah. In some cases, companies had their own proprietary email system. So see, it is not that that email has launched, by, I think, Sabir Bhatia. You must have heard, okay, about him. Who is Sabir Bhatia? Have you heard about him? Anyone? So if I type email innovator, let's see who is the inventor of email. Okay, so internet pioneer Ray, Tomlinson, who is credited to the invention of email. Uh, okay, who invented Gmail, and that's the story about Gmail. So originator of email, let's see. So Ray, Tomlinson is most people give a title of email inventor. He came up with the idea while working with ARPANET. That's what I'm saying. You don't say that Sabir Bhatia has invented email. I ask questions in many forum and they come and say that Sabir Bhatia. No, it's not like that. So Ray Tomlinson was the one who introduced the concept of the email actually. Okay. Uh, uh, while working with the ARPANET, the government funded research project that eventually became the internet. At the time you could only leave message for people using the same computer. Okay. And I think wherever you search, only his name will be the father of email. Okay. Ray Samuel, American computer, and so on. So it is not that there were no communication between the machines. Yeah, there were communication happening. Okay. And you can't talk in any forum saying that since net was not there, so you know there were no communication. And so I already talked about few more over, like they're saying so here's a more detailed breakdown, like early method of it's a similar thing between computer, like R32 or some special interval modems. Also modem allow computer communicate over telephone line. We already gone through in more depth. Answer reading fuel offline data transfer I talked about. In the era of batch processing, data was often transferred using physical media like magnetic tapes, punch card, or paper tape. You can read more through if you get a chance. And early network like DC net 70 use point-to-point connection to link computer together. Okay, so there are many such things were available. Yeah, but the complex at that time, now it looked like that it was complex, but that time it was an invention. Okay, such a fantastic thing. Okay, so if I ask you a question, you know how does two application communicate with each other? Two different application communicate with each other. Anyone? So my problem, friends, that I keep on talking and I keep on asking more questions. The two thing I do it very regularly. Okay. So I have a Java application. I have a .NET application. How both of them gonna communicate with each other? Is it that easy or is it tough? Your thought around it, everyone? So what we have completed till now, uh, you know, is that we just communicated that was there any kind of communication between two computer before internet? Yes, it was there. There was a BBS. There was a something other through modem direct connection was there. In fact, we were using a magnetic tape also. Okay, so basically, yeah, through server, fantastic. Ultimately, it happened through a server. But my question is that, yeah, obviously you need to have some kind of communication. I mean, you have some kind of way to reaching to them. So thank you so much, Vishwa. Yeah, fantastic answer. So through server. Okay. Now, if I take this question to a more depth, okay, and let's say here, so I have a .NET application. Okay. So as per Vishwajit, they communicated through server, that is done, communication established, and then I have a Java application. Any idea how do they communicate with each other? So Vishwajit says server, that's okay. After connection, and with server, okay, with help of us, let's say a web server, okay, they communicate with it. Then now how they we gonna talk to each other? Anyone? How they will you know do the, just a minute, uh, exchange of the information? Anyone? How they will do an exchange of the information? Are you getting this question, or is there some doubt? So Vishwajit answer one query through server. So let's say they communicate. Okay, now I'm able to get connect to you. Okay, it's like we have communicated over two telephone. So through server, Java and .NET application communicated, like, we communicated over telephone. Now, how to proceed the, talk, or how to do a further talk? So, any thought around it? Anyone? Before you go ahead, can anyone told me Ronak or Rohit, or Snehal or Bishwajit? Okay. What are the list of 4 subjects you've gone through, in last semester? So thanks, uh, Sunil. Yeah, REST API. Yeah, that also one way, but we're gonna going into more depth about it. So, which are the model being taught in last semester to all of you? Can you just name it? Few 4 modules. Quickly, friends. See, your interaction will help me to take this ahead, or else if I'm interested in just going through PPT, then I can't help it. Sorry. So my question was that which are the 4 subjects you completed in last semester? That's what I'm asking, so that I can relate the example accordingly. 4 subjects you completed in last semester. Okay, computer network, OOP, fantastic. And which were the other 2? Thanks, Anchal. Which were the other 2? Okay, network programming and I think one is also one is remaining now. Okay, fantastic. Okay, network security. Thanks, Usha. Yeah, then you must be able to answer this question. Thank you so much. So, how .NET and Java application gonna talk to each other? Let's say they connected over network. Okay, now how they gonna talk to each other, and what are the challenges in their talk? Quickly, friends. Anything you would like to share here? How .NET and Java? Okay. Uh, so do you think the their interaction will be easy, or is it data storage technique and network? So Salma is saying data storage technology and network. Okay, okay, fine. Okay. See, what is my challenge here? I'll tell you. Okay. So .NET will say, okay, I want to call function F1. Okay. It will pass this information to a Java, but then how does Java will understand? Okay, that the function call F1, which is in .NET, is actually it could be something else in Java also. You're getting the idea what I'm saying? So let's say maybe let's say English, okay, or maybe you are knowing, let's say Hindi, and I know, let's say Marathi, for example. So Marathi means I am a Java language, and Hindi means you are a .NET language. Okay, though we are connected over the phones, okay, which is through some server, okay, or some whatever, some technology, okay. But then how should we take our conversation ahead? That's the question. Because I understand Marathi, you understand Hindi, okay. So, but I don't understand. Both of us don't understand our language. So that was the question. Anyone? So, you know, so web technology is more about it's more about obviously the HTML, XML, CSS, JavaScript, and PHP. Okay, that's definitely we're gonna do it. But this concepts you have to understand very well. Okay, so they were communicating with help of something called as web services. Okay, so all those communication were happening with help of the concept called as web services. Okay, this web services using a protocol called SOAP, simple object as protocol. which is in XML. That is where your XML is also important and has been mentioned in this handout. Okay. So you have HTML, you have CSS, you have JavaScript, and you have XML. Okay. So here it will be a communication not between the server, but also between the application. Okay, you need to understand. So .NET and Java, whatever they are doing, they will, you know, you take a help of web services to communicate with each other. Okay, and they send their message in the XML format through simple object access protocol, and then in turn, so they will actually basically communicate, using XML. So like if I know Marathi, you know Hindi. Okay, so we have a common translator language which is called English. Okay, so whatever I talk, it will go. So I will talk in English to a translator. Then this English guy will again talk to a in their own language to a .NET. Okay, so that's how the chain of communication will transfer. Okay, so web services. Remember, if someone asks you, so web services is such a technology. That is the reason why all the communication are happening across heterogeneous application. Okay, and it's not that easy. Even Visual Basic language. Okay, so I'll tell you. I don't know how many of you know Visual Basic language, but in Visual Basic language, uh, this F1 could be a function, it could be a variable, okay, or it could be. So there are two different meaning for this name called F1. It can be a variable also, it can be a function also. Because in Visual Basic, if function, I'm talking about the language called Visual Basic over here. Okay. So Visual Basic. Okay, so if your function does not take any parameter, then you can just call it by a name. Okay, or you can call it by this way. So that is how the story is. Okay. So Visual Basic itself having a confusion in its own programming language. Forget about how do you communicate between .NET and Java. Okay. So today is a world of more world of obviously exchange of information. Obviously you need a servers for that. And once information is being so before exchanging, like Vishwaji said, that we need to connect. So once you connected, how would you exchange the information? Okay, you come on the telephone call, how would you connect with each other? Okay, so there are whole lots of the technology goes behind it. Fine, so that's the reason. But all of you given a right answer. Okay, that was great. Okay, so now I already talk about the idea of the internet. Okay, so they wanted the communication anywhere, anytime, and on any device. That was the concept. Anywhere, anytime, on any device. Okay, that is where all this started. Internet and so on, and obviously the credit goes to US Department of Defense. Okay, so the purpose of this so they started developing a large scale computer network. The purpose of this network were communication, program sharing, remote computer access for researchers working on the defense contract. So earlier they target only the their own defense and for a military purpose, but then later on it was basically um, open for all. So the DoD Advanced Research Project like ARPA funded the construction of the first such network, and it was named as ARPA. So they were basically a the financier of this. Okay, that's why it is majorly named it ARPA. So there is no such reason. Is only that they funded it. So the primary and the early use of ARPANET was simple text-based communication through email. Remember I think we also talked about the email. Was there. Don't say that email was not there. Don't talk in that way. Okay. So that is how the journey started. Okay. And then slowly and slowly everyone started pitching. So there was a BitNet, which is acronym for, because it's time network, began at the city of University of New York. So New York, that's where the BitNet also involved. Then there's a CSNet, acronym for Computer Science Network. His initial purpose was to provide electronic mail. So they also chip in and help to build the entire system. In 90s, what happened that the NSF net, which was created in 1960, replaced by ARPANET by 1990. Okay. So it was sponsored by National Science Foundation. So by 92, SFNet connected more than 1 million computer around the world. That was something amazing. Okay, 1 million. See, before the internet or even the launch of the internet, the scale of connection, or the interaction between the machine was still, uh, it was still very, less. I mean, uh, if they used to connect to a 10 people, story gone. They won't be able to, then proceed further. So that was the, so when I'm saying 10 people means, the application talking to a one machine talking to a 10 machine, So then it was on toss. So that's how it is. But then they gradually in the increase of the system and so on. So in 95, in 1995, a small part of SONet turned into being a research network. The rest become known as internet. So 95 is the era where it was a full fledged you know uh, what is called the okay. So do you know that in India, the in which year it has become very famous in India? Anyone? So in India, in which year was the boom for the internet? Everyone started using internet. Any thought around it? Anyone? In the India, in which year, everyone, started basically, and wanted to know more about the internet. So yeah, so in India, and we were lucky that Rajiv Gandhi has brought that machine. Okay, so we must give a credit to him, because he brought computers in India. We were able to started leveraging the concept of the internet. So from 97 onwards, there was a boom in the market. Everyone, started opening a cyber cafe, because, it was something that, people were getting, more information, over the web, over the one place, you remember cyber cafe, was there. It was a boom of the cyber cafe. 97, I think till 2000, I could say, maybe, 9 or 10 or 8, it was a huge, like business for a cyber cafe, proprietary. It was a great hit actually. I don't know, like how many cyber cafe exist. I don't think we have any cyber cafe existing. It could be hardly, in less than 1%. Okay, but it was a big boom. Okay, so it was something, the idea that they were getting a more content out of it. They were able to communicate with each other with help of the chat. You know, chats were available in the email facility were available and so on. So look at the journey. It has basically created a strong foundation for all types of communication. So they started 1960, but it has become a foolproof network where there were no limitation on number of connections, and so on. And 96 it was a blast, and then 97 till 2009 or 10, and it was a full page. Okay, so we are already know about this. So internet is a huge collection of computer connected in a communication network. And internet protocols use transmission control protocol. Internet protocol is used to link the device. This protocol is being used to basically link the device. The individual computer in are connected to each other in the local network. Okay, so one node on this local network is physically connected to the internet, and the internet is actually a network of network of network. Don't say just a network of network. It was network of network of network. Okay. So through between two machine, then between 10 machine, those 10 machine may be two machine may be in your home, 10 machine may be in your offices, and then office to a city, city to a state, state to a country, country to a country, and to a country, and to a country. Okay, and to a country. Okay, and across globe, and then across planet. Is it possible we can communicate across planet? Anyone? Is it possible that internet still works across planet? Anyone? Is internet works across planet also? So we started from a home, two computer. We went to a office, 10 computer. Just for example, more than 10 computer in a big offices like Wipro. I think 1 lakh computer right now sitting in any of the Wipro offices. Okay, then city, state, countries. Is it possible to communicate across planet? Anyone? Any thought around it? Is it possible? I mean, my question, Sandesh, you want to like share a view? Sandesh or Rohit? Fantastic, Bishwat. Yeah, it is possible. Okay. And forget about planet to planet. We are communicating, out of our solar system. Okay. And I'm not talking hypothetically. Okay. We have Voyager 1. How many of you heard about the Voyager 1, friends? Voyager 1. Look at this is the power of our internet. Okay. See, Voyager 1. Let me just go and, type this. If you're talking about communicating between two cities or within the country, between the countries, forget about it. Let's
Imagine
see.
a world without mobile phones. No
Just a
texting,
minute.
no selfies, no Google Maps. It's hard to believe that the first mobile phone call was made just a few.
Just a minute. Sorry about that. Yeah, I'll show you this. Look at this video, friends.
In 1977, the Voyager 1 space probe was launched to study the outer solar system. The two Voyager space probes have become the longest operating spacecrafts in spaceflight history. 41 years later, Voyager 1 is now 21 billion kilometers from Earth and traveling at 61,000 kilometers per hour. Despite Voyager 1 being the farthest man-made object from Earth, we are still able to communicate with the space probe on a regular basis. But how far can it go before we can no longer communicate with it? To answer this, we need to know how Voyager 1 receives and transmits data from 21 billion kilometers away. A 20 kilowatt signal is transmitted from Earth to Voyager 1 using radio waves. It takes almost 20 hours for the signal to reach the space probe, where its sensitive antenna picks up the signal. For comparison, it takes the rovers on Mars an average of just 15 minutes to send messages back to Earth. Voyager starts sending data back to Earth using a 20-watt signal. As it travels through space, the signal strength weakens, and by the time it reaches Earth, the signal is barely detectable. In order to communicate with objects that are this far away, it doesn't really matter how strong the signal is, as long as you have a receiver that is sensitive enough to pick it up. NASA uses the Deep Space Network, which consists of 3 antenna complexes equally spaced around the Earth. Each complex has a huge 70-meter antenna, along with multiple 34-meter antennae, which can be combined to pick up signals that are thousands of times weaker than your standard FM radio signal. The Deep Space Network spends several hours each day listening to faint signals from Voyager 1, and so far, it continues to talk back to us. Since our methods of detecting signals has improved drastically over the past 50 years, there isn't really a limit on how far we can communicate with objects in space. With our current technology, we could reliably communicate with objects that are many light years away from us, as long as our receivers are sensitive and accurate enough to.
Yeah, so that was just a small video. So, so it's such a power of internet. You can't limit it. And so only one thing I keep on repeating: anywhere, anytime, and on it, any device. And now look at the anywhere term. Okay, this anywhere term, basically there is out of our solar system. Okay, the Voyager 1, and still we are able to communicate. Such a fantastic power of this internet technology. So you should never basically you know uh, underestimate this. Otherwise, again, that is why we are able to, and it has helped us during the lockdown also. We are able to run this entire session over the net, uh, friends. Okay, so uh, yeah, okay. uh, And you can, start comparing, earlier, the or communication, message communication, like through the post office, we used to write a letter, and now look at the technology being advanced. It's just under your fingertip. You just send a message, SMS or WhatsApp. Story is closed over there. Okay, so you should actually go through this video. How does, very important part of it. Uh, we basically always listen to this expert, what they're talking about the internet. And let me share this quickly.
इस बार मैं सोसाइटी इलेक्शन जीता तो बरसात से टपकती शाल बदल दूंगा, गड्ढों का हाल बदल दूंगा।
गुप्ता जी, मिसेस से कहकर पहले अपनी चाय बदल लीजिए। बरसात आती है आपको सर्दी खांसी हो जाती है। रेड लेबल नेचुरल केयर चाय लीजिए। इसमें है 5 आयुर्वेदिक तत्व जो अंदर से स्ट्रॉन्ग बनाने में मदद करें।
This episode of Life Noggin was brought to you by Audible. Hey there, welcome to Life Noggin. Thanks to this wonderful thing called the internet, you are watching this video right now. But how did the internet get to where it is today? There is so much internet history that we couldn't possibly get to everything in this short of a video, so we're definitely going to have to make a second one. Anyway, let's get started. The internet actually got its start over 50 years ago, and computers back then filled up entire rooms. Scientists and researchers used it for years to communicate during the Cold War. It was useful because if one computer went down, the others wouldn't follow. In 1962, a scientist named J.C.R. Licklider proposed the idea of a network of computers that could talk to one another. In 1969, the first ever message was sent from one computer to another over the ARPANET, the government's computer network at the time. ARPANET stands for Advanced Research Projects Agency. One was located in a research lab in UCLA and the other at Stanford. All the message said was log in, and it didn't fail to crash the network. Stanford only received the first 2 letters of, but hey, you gotta start somewhere. By the end of the year, only 4 computers were connected to this network. In 1971, the
Yeah, so first message, which was sent was login, and again to that, they were able to send only, hello. Okay, so very interesting. This we had already discussed the all about how it is started. We are listening to an expert view.
University of Hawaii's Aloha Net was added, followed by various networks in London and Norway 2 years later. Also happening in 1971, Ray Tomlinson was developing the first system to send mail
So, we already talked about Ray Tomlinson. It's just a summary of whatever we discussed.
back and forth between the users of ARPANET. This would eventually be called electronic mail or email for short. The @ symbol was used to tell a person's name and the host name apart. With all of the networks floating around, there needed to be a way for all of the computers on them to communicate.
So good story about the @ symbol also. It is not that started immediately. Yeah, there was a thought process, and then that's where @blog.com, this thing originated in the beginning. It is not that 2010, 12, 15, or whenever you started using internet, you started. I think you must have been started using internet in your, I think maybe your, childhood days, if I'm not wrong.
Communicate with other networks. This is where computer scientist named Vinton Cerf comes in. He invented a way to introduce computers across the globe to each other in a virtual space. This invention was called Transmission Control Protocol, or TCP, which was followed by Internet Protocol, or IP. In the 80s, scientists used Cerf's protocol to send data back and forth, and it really all began. In 1991, a computer programmer named Tim Berners-Lee invented the World Wide Web. This wasn't just a data sharing space for scientists anymore. This was an entire network of information that was accessible to anyone with an internet connection. You're using a browser right now to watch this video, and some of the popular ones are Firefox, Google Chrome, and Safari, but in 1992, Urwise was created. Urwise was an internet browser and the first to have a graphical interface. A few browsers came before and after, but in 1993, Mosaic was created, and it would popularize surfing the web. Mosaic influenced many of the browsers to follow, including Netscape Navigator in 1994. This became the most popular web browser at the time, accounting for 90% of the web usage in 1995. In the early 90s, companies like AOL and CompuServe were starting to provide dial-up internet access. Dial-up is a method of connecting to the internet via a telephone line. Your telephone line was plugged into a modem, and the other end was plugged into the phone jack. There was a period in history where you couldn't use your telephone and the internet at the same time. Without the internet, we obviously wouldn't have things like Facebook.
Yeah, so I'm not sure whether you had this kind of problem, but yeah, I used to have this problem. Okay, so I can't. So whenever the call is to come, modem is to go down. Okay, So anyway, that
Facebook, Twitter, and
does not
YouTube.
exist now.
But way more importantly, we wouldn't be able to access information in seconds. We wouldn't be able to communicate with people from around the world, share ideas, and educate those who might not get a chance elsewhere. Also, without the internet, I'd actually have to talk to someone when I order a pizza, which, by the way, was the first thing ever purchased on the internet. How would your life be different without the internet? Let us know in the comment section below. See Audible.
Yeah, it's just
Go to audible.com/lifenoggin to get a
summary about it. I think you're already aware about the internet, but as a part of the course handout, we have to actually discuss on it. So that's one thing. Let's go to a next after understanding the internet need, how it is started, and so on. So World Wide Web, like Tim Berners-Lee, as he started, we just now heard to him. Okay, so it's a primary application program on the internet. The internet, it's a collection of computer. We already provides many services. The World Wide Web, electronic mail, multiplayer, online game, internet, telephony, file sharing, media device. Okay, so original Tim Berners-Lee, he proposed the idea of the web in 1989. So sharing information or hypertext document, hyperlinked text document. Okay. So there were document pages, other web resources like uniform resource locator and so on. And web pages are unloaded with the HTML. Okay, and web pages may contain images, video, audio, and software component also. So that's how the web originated. Okay, and it was overall idea of the Tim Berners-Lee. Tim Berners-Lee is also the inventor of HTML, hypertext markup language. Yeah. So I don't think we need to go through this, but yeah. Okay. Also, the client server architecture is very important because over the web there were many applications being placed. Okay. So client server architecture has also plays a very vital role in all this term. Okay. So web operates in the client server architecture, web client or browser. A browser is a client on the web because it initiates the communication between the with the web server. And what are the web server? Web server is a program that provide document to a requesting browser. Okay. So it's a server where whole you could have a database, you could have a files, you could have anything over there. Okay, and whatever request being there, web server there's a program which runs and identifies where it is possible or not. Okay, so what we can do, we can see the video on the web server, just a small video on this. Since this is a very interesting concept, and we do this is about the
हर दिन चाहिए सालों वाला look,
client
है ना?
architecture.
पर हर दिन सालों जाना impossible. तो फिर
But Kiara, salon to carpet.
We can,
Trust me, Kelton Smooth, your salon professional.
what we can do is that we'll first understand this World Wide Web, and then we can have a discussion on this.
So what's the web? It used to be difficult to explain what the web would be like. Now it's difficult to explain why it was difficult.
In 1980, when we used fax machines to share documents and travel agencies to book flights and hotels, Tim Berners-Lee, a young Oxford graduate, first came to CERN as an independent IT professional to computerize CERN's proton synchrotron control system.
But back in the 1980s, at CERN, it was an exciting place to be. Lots and lots of information systems on different computers, on different networks, all in compatible. So the idea was that one should be able to communicate by sharing information.
He needed to understand the mass of information and how to link people, hardware, and software.
So he's thought of like this. See the information were there on different network, different computers, and anywhere on any device. So he's thought that we can bring those at one place. Okay, and we can give a the kind of the standardized way of basically in fact accessing of those content, and not only accessing, because the earlier idea started with the exchange of the information, Now it also, went to excess of the information. Okay.
For that, he wrote a program and named it Enquire, after a Victorian reference book he remembered from his childhood for giving easy access to a mass of useful information. Then he went back to the UK. When he returned to CERN as a fellow in 1984, the laboratory had grown to become a leading center for data network, and he wrote software that ran over them. In 1989, he saw an opportunity to join hypertext with the internet.
So CERN was an interesting place to be. It was, yes, it was advanced. It was somewhere where in 1989 most people had some sort of a workstation on their desk, which was unusual then, and a place where the internet, the network connectivity had just arrived. Well, the network connectivity had been there for a while.
Using similar ideas to those underlying the Enquire system, Tim wrote the first proposal for the World Wide Web in March 1989 and his second proposal in May 1990. Together with Belgian systems engineer Robert Caillot, this was formalized as a management proposal in November 1990. By the end of 1990, Tim Berners-Lee had the first web server and browser up and running on his next computer at CERN.
The number of hits on this machine, which started off as 100 a day, then a year later it was 1,000 a day, and then a year later it was 10,000 a day.
In 1991, the first web server outside of Europe was up at SLAC, the Stanford Linear Accelerator Center in California. Many would follow. In 1993, CERN management decided that the web should act as an open standard for all to use. That was an essential decision.
So the web we have. If we had not had that document from CERN, we would not have the web.
Today, with nearly 2 billion websites, we do not remember and cannot even imagine a world without the World Wide Web.
Yeah, see, we are all aware about all this. Okay, so the idea of showing this video is that let's see what had exactly happened, how it is arrived. So that's what it is. Okay, I mean, so on. Okay, the client server architecture is again, a very important part of it in now today's world. Okay, so one there's someone who is requesting for a service is a client, and someone will provide the service is a server basically. Okay, so that's how the client server used to operate. Very fantastic concept. I must say that if I can. So how many client server architecture you are aware about? Anyone? So it was like let me see if they have explained, otherwise I will explain. No, it is not. So switch off this. So we used to have a earlier. So this is a client server architecture, client server. Okay. So client will request. Okay. Request and server will provide the service. Okay. So before you understand that, before we go ahead and get the idea about it. So the client server architecture, basically how it is operated, and so what they say that if I'm developing an application, okay, and in any any application we are creating, okay, it will always have a three parts. One is called as first section UI, or you can say presentation layer. Okay. this one. Okay. Or somebody will also call as front end. Okay. So, and then we have another section called as application logic or business logic. Okay. And third is the database server. So they're divided, basically into a three category. The UI presentation of front end, okay, front end, fine. Then application logic and database server. Okay. So what could be a content of these three? Anyone? If you can help me with the answer. What are things stored over here, friends? What do you mean by presentation, UI or front end layer? Front end. What do you mean by application logic and what do you mean by database server? Any thought? What are things stored over there? Anyone quickly? Am I audible? Hello? Chandan, you want to share something? So whenever application, we create, it is a very full, large scale, and it always has a three major component into it. One is UI presentation or front end. Other is application logic or business logic, and third is database. So what are these three actually, friends? What these three consists of? When you say front end, what do you mean by that? When you say application or business logic, what do you mean by that? And when you say database server, what do you mean by that? Any thought? Okay. So Acha says presentation layer, user interacts. Fantastic answer. So presentation layer is or front end UI is where actually is a landing page, is a landing or the front end where user will start interacting. Fantastic answer, Anchal. That is one. When I say application logic or business logic, it is that is the processing of the user request. Okay. So let's say I have a I launch an application, addition of two number and I launch into the website. Okay. So now to access that application, user will go through a front end. He will hit that website through a through his mobile device or whichever device through a browser. Okay. So that is called presentation. The moment he hit that, he'll get some some landing page that is called the front end or UI page. Okay. Now he will input to number. Now click of that number, the request will goes to a web server or whichever server for processing. Okay, fine. So and then those business logic will be processed at the server side. Okay, so that is what is called business logic or application logic. Now the business logic can be anything. It can be like you want to get some information from a database. Okay, again you need a business logic. Okay, and so on. So that is basically written using a server side technology. Okay. So this business logic actually written using a server side technologies. Okay, fine. Uh, fine. And what is a database server? This database server basically responsible for holding a storing a database or any files and so on, onto the one a machine or a server. Okay. So in the same application three parts: presentation layer, business logic, and the database layer. Okay. So in the client server architecture, okay, fine. So client used to or end user used to request through a front end, the any kind of information. It goes to a application or logic or business logic or application server and so on for processing of those information. Let's say you want to see what is my balance in the account. Okay. So in terms of landing page, you input your data, whether you're a right account holder or not. Those business, that is called the application of business logic, that gets posted on the server side, and whatever response will be returned to you. Okay, and if anything is to be retrieved from database. Okay, and so on. Right. So in the client server architecture, all this so there were different types of client server architecture. We used to have single tier. Okay. So in single tier and during mainframe days, everything was on one machine. Okay. Everything was on single machine. That's why it used to call as single tier. Okay. That means on the same machine, we used to have the front end, business logic and the database. Okay. Then they started with a two tier. Okay. So in two tier, the front end on client device, or it could be any device, but the business logic and database on one machine. Okay, that's why it used to be called as two-tier architecture. Okay, uh, so front end through any devices. Okay, you accept from mobile, tablet, laptop, desktop, and so on. But the corresponding business logic and database on another machine. So it is two-tier. Front end is on you can access from anywhere, and but business logic and the database on the one machine. So it was a two-tier architecture. Okay, then what they were done, they shifted to a three-tier architecture. Now what could be a three-tier architecture? Anyone? Three-tier architecture. So in three-tier architecture, what they have done, so front end or UI was as it is, but they shifted the business logic and the database server. Okay, so what they have done earlier, business logic and database server was on one machine. So they again done a categorization. They have one server which is holding a business logic, then another server holding a database. So they separated this way. So it has become a three tier. Okay, can we have n tier? Can we have n tier architecture? Anyone? More than three tier or n tier? Anyone? Is it possible to have n-tier architecture? So we started with a single tier where a presentation, business logic, and database on one machine. Then we went to two tier where we separated presentation from a business logic and database. Then we went to a three tier where UI was as it the client side, but the business logic on one machine and the database logic on another machine. But can we have more than three tier architecture also, or n-tier architecture? Anyone? Any thought around it? Is it possible that we can have a more than three tier architecture? Yes, no. Aryant, you want to share some idea? Is it possible to have more than three tier architecture? We started with single tier, we went to two tier, we went to three tier. But is it possible to have n tier? Just query. Dinesh is not responding. Parul or Kavita, Sandesh. Is it possible to have n tier architecture? Yes, no. Am I audible, friends? Chandan, anything from you? Chandan or Ria? Is it possible to have n tier architecture? Suhel, Omkar, Jay Kamble. Is it possible to have n tier architecture? Am I audible, friends? I hope we are getting what I'm talking about. Everyone, yes, no, quickly. You're understanding what I'm talking, this entire thing. Hello, am I audible? Hello. Okay. Thanks, Devshir. Thanks, Salma. Appreciate. Yeah. Yeah, so we can have n-tier architecture also. N-tier means there could be any other any types of layer. For example, one layer could be your front end. So like we started with front end business database, and I have actually seen that they had also introduced a one more layer, between business logic and database, that is called as a security layer. Okay, security layer. So that is also possible. See, kind of, you can have a kind of different category, to store and so on. Fine. So what is the benefit of this client server architecture? Anyone? What is the benefit of the client server architecture? Any thought quickly? What is the benefit? I hope you got it. What is the client server architecture? Yes, no? Quickly. Did you get it? What is the client server architecture? Thank you, Vishnu. But then what is the benefit of it actually? How does it provide the benefit? Client server architecture to an end user? That's my query. There are again many pros and cons of this that we are not discussing it. But then what's the benefit of the client server architecture? If someone asks you that, in the interview or in the exam, how would you answer that? Anyone? Benefit of client server architecture? So again, the programming, sorry, the language, the coding which we're gonna do from next context session. Okay, remember you gonna do coding, not I. Okay, I'm just gonna launch a code in front of you, and I'm gonna ask every one of you. Okay, so you have to be interactive, friends, over here. So my simple question, see, share your thought. I'm not deducting your marks, okay, that you said right or wrong. So simple question, benefit of client server architecture. What kind of benefit end user will get? Enterprise will get. So yeah, I got an answer from Vishnu. Thank you so much. It provides a simple way for user to interact with the server and use the application it sold. Yeah, fantastic answer. Actually, imagine, if client server architecture is not there, what would have happened? You have to travel from if that entire machine, that used to happen during a mainframe. The entire application, and it's a reality actually. The application, let's say, if it is hosted in, let's say, Kolkata, and if I'm staying in Mumbai, Bangalore, or Chennai, or Hyderabad, you have to actually travel to Kolkata to access that application. That was the scenario earlier, friends. That was the scenario. Okay. Yeah, thanks. Answer. Yeah, user will not have to interact much with the server. It will have to interact. Yeah, I mean that is also being sorted out. Thanks. Rightly said. Yeah, and so that is where, and that is where started. That's their segregated. There's client server architecture. They put database business logic in one machine, then front end on another. Then similarly, front end is basically any end client can access from anywhere. Then they thought that the putting database server and business logic on one machine is a bottleneck. It's basically a basically load on the server. Then they segregated it. Okay, so they created one more server where they store a business logic. Then say that, so that is how it become TDI architecture. Then say that we can also have one security layer in between it to make a system secure. So because in 2000, after 2005, security has become one of the important parameters. Nowadays also, we are talking about cyber security. So they created one more server in between to take care of this, threats. So that's why this, then this it has become an entire architecture. Okay. So rightly said. So what I'm going to do, there is one small video of a entire. We can definitely, have a look about it and see what experts are saying. Let me gonna launch this, and then we'll proceed with the next.
As a working professional, do you hesitate to speak in office meetings and presentations?
Sorry about
Do
this.
you feel underconfident while taking project initiatives?
Hello guys, I am a bot and welcome to our channel Bot Engineer. Today I come with a new topic, client server architecture. In this session we're gonna discuss on client server architecture and its types. So without wasting our time, let's get started with our today's
It's just a
topic.
review of whatever we discussed.
Client server architecture. Client-server architecture is a distributed application structure that partitions tasks or workloads between the providers of a resource or service, called servers, and service requesters, called clients. In client-server architecture, the client requests a resource and the server provides that resource. A server may serve multiple clients at the same time while a client is in contact with only one server. It is a general-purpose architecture where client request for any kind of resource or data to the server. These both client and server are connected to each other via internet. Server intercept the request, process it and fetch data from the database and send it to a client in form of response. Database is the place where and information are stored. There are three types of client-server architecture. One-tier architecture.
So there are n tier also, not only 3 tier. This we had actually we had restricted till 3 tier, till 2000, I think, 2000 maybe 10, but then thereafter we have then started with the n tier just because of the security. Okay.
Tier architecture.
Security layer.
Three-tier architecture. One-tier architecture. One-tier architecture is that where the client, server, and database all reside on the same machine. Anytime you install a DB in your system and access it to practice SQL queries, it is one-tier architecture. For example, while creating a web application by Java programming language, we have install Apache server and MySQL database within our machine to run our web application. We don't need extra physical server and database outside our computer. Two-tier architecture. A two-tier architecture is that where presentation layer runs on a client and data is stored on a server. In this architecture, a client request for data or resources to server and server process that request. In Tier 1, our client resides in Tier 2 server and database are occur.
So your database and the business logic on the one server and the presentation on client.
Both tier are communicate with each other through the internet or any network. This structure is quite easy to maintain and modify. The communication between the client and server in the form of request, response, and messages transfer is quite fast. The major drawback of this structure is, if the client nodes are increased beyond capacity in the structure, then the server is not able to handle the request overflow and performance of the system degrades. Three-tier architecture. The three-tier architecture has three layers, namely client, application, and data layer. The client layer is the one that requests the information. In this case, it could be the GUI, web interface, etc. The application layer acts as an interface between the client and data layer. It helps in communication and also provides security. The data layer is the one that actually contains the required data. This architecture contains an application layer between the user and the DBMS, which is responsible for.
So why does application layer sits in between a client and a database? Anyone? Why does application layer sits in between client and a database server? Any thought? Any thought around it, friends? Quickly. And what was the reason of fitting application layer in between database server and the client? So very simple reason, to just give database access only to a as and when required and to authenticated user. Okay, that was the reason. It cannot be directly accessed by all without any further validation. Okay. See, it may happen that hitting a database server is a costly. Okay, so as long as we use a less resource on the this server,
for communicating the user's request to the DBMS system and send the response from the DBMS to the user. The application layer, also called business logic layer, that processes functional logic, constraint, and rules before passing data to the user or down to the DBMS. Three-tier architecture is the most popular DBMS architecture. The main goal of three-tier architecture is to separate the user applications and physical database, program data independence, and support of multiple views of the data. So that's all for today now. I hope this video is informative to you. We will
Yeah, that is only for the revision purpose, not to. Okay. So very important, in fact, they have now NTR is a famous one. They basically what they've done after front end, they had placed a persistent layer. Sorry, not what is that? The security layer in between. In fact, they are not allowing you to cross the security layer to go to even application layer. Okay. So they keep on checking whether is a right user is accessing, or is a right browser has been requested from right area it has been accessed, and everything. It is much more secure nowadays. Okay, so this was about the client server. Then we have web browser. Without web browser, coming on the net is not possible. So it is one of the platform where you start interacting with all types of this application. Okay, so Mosaic NCSA was there. We already seen Linus. It was stated. Linus, sorry. Browser or client always initiate. Server react to, sometimes server require responses. Okay, most requests for existing document, HTML, transfer protocol, and so on. But some requests are for program execution with the output being written as example Firefox and so on. Okay, so what web server does? So through browser you start connecting. What web server does? They provide a kind of data you are requesting. It could be either in terms of any document, or but all the responses will be happen only in the form of HTTP. Okay, so you request in any way, but the response on the browser will happen only in the form of HTML language. Okay. So role of browser, web server, provide response to a browser request, existing document, dynamically built document, whatever. We're going to talk more about dynamically built document when we do a PHP and so on. Browser server connection has more than one request response cycle. So there's a proper request response cycle is there. All communication between browser and server uses HTTP protocol. Web server runs as a background process in the operating system and monitor communication through port 80. So 80 port is where this the entire web application runs. Okay. Then along these three important things we need to always remember: uniform resource locator, a system of globally unique identifier for resource on the web. So through URL we need to type. Then published language HTTP markup. Like I said, that the response will come in the form of hypertext markup language HTML format. Whichever form you request, response will always come from a server in the form of HTML, and the entire communication will happen through a hypertext transfer protocol, which is used to send information over the web. That's what it is. And this is the working of the web. You type the website name. Okay, in terms of the English language, you just type, or French, whichever language you type it, it just look into you know uh, domain name, server. If it is found, the corresponding IP is mapped over here. Okay, once IP is mapped there, then this send that means you're connected to a web server. Again, once you connect to web server, then you start sending a request. The request could be foreign. You want to see the that your account balance from particular website. Okay, and this website is hosted on a, let's say, HDFC bank server or any bank server. Okay, then whatever request being sent, the web server will process it, and and this web server, usually the whatever the request that is sent in terms of client technology, like HTML, XML, or CSS and whatever. Uh, and to process those logic, we have server-side technology like PHP in our case for this semester. They process the information, they send back in the form of HTTP, and then to back to a browser. So that is in short. But in depth, there are many such things are involved for this working. Okay, so like there's it search for a domain name. Maybe it is stored in a cache. It is stored in an operating system cache. If it is not found, then it goes to a particular domain name of the service provider. If it is not there, then it again go to a further domain name that and if in the case it is not found, IP is not matched, then it is not found. Otherwise, then one is connected, then it follows the own request response cycle. Okay, so remember, request will happen through HTTP. Response will also come in the form of HTTP, and it's always HTML. Okay, so very simple flow mechanism. We're gonna see in more depth. Okay, So what I'm gonna do that I'm gonna share the one important let's say this expert view for all of us. Let's just have a look at it. Very interesting. Let me launch it. Wonderful. And it is in more depth. First, it talks about the DNS. We may not go in that depth.
So you just mentioned that you want to learn Python. So do not learn Python in manual way in 2025 because learning Python in manual way will take you like 6 months.
Hey guys, this is DG. Today we are going to learn what DNS numbers called IP addresses. They do not understand human languages. If computers do not understand human languages, how they load a website when we type its address in the web browser's URL bar? That's the place where DNS comes in. Suppose we speak English and we want to communicate a person who speaks French. For effective communication, we will need a translator. Same is the case on the internet too. Computers or web browsers understand IP addresses and we humans understand our languages, say English. DNS acts as a translator between humans and computers. DNS or domain name system maintains a table where names are mapped to numbers, or more specifically, where websites' domain names are mapped to their IP addresses. Now, when we type google.com in the web browser, DNS translates it to the web browser's language, that is IP address, and gives it to the web browser. Now, web browser understands that we want to access google.com. So it contacts the Google server and loads google.com on the computer. In short, DNS acts as a phone book of the internet, where computer searches with names to get numbers. So, how DNS works internally? To understand this, we should know what are DNS servers. Servers are computers storing HTML files, images, sounds, videos, or any other file types. Servers that work together to provide IP address of the requested website to the web browser are called DNS servers. There are 4 types of DNS servers: DNS Recursive Resolver or DNS Resolver, Root Name Server, Top Level Domain or TLD Name Server, and Authoritative Name Server. DNS Resolver is provided by the Internet Service Provider. It connects the web browser of our computer to the DNS name servers. There are 13 sets of root name servers, logically named as letter.root-servers.net, where letter ranges from A to M, and are operated by 12 different organizations. Each set has a number of servers placed around the world. An informational page exists for all root name servers at address letter.root-servers.org, where letter ranges from A to M, except G. For G, this is the home page address. Details of all root name servers can be found in the website www.root-servers.org. TLD name server stores the information of all domains sharing a common domain extension. For example, .com TLD name server stores the information of all websites ending with .com extension. .net TLD name server stores information of all .net websites, and so on. Authoritative name server is the last server in the domain name system. It stores the IP address of the requested website. Authoritative name server for a website can be found with these CMD commands. Open CMD and type.
Yeah, so that can be very easily found. If you can just type it on the CMD, I'll show you that. So it's NS, lookup. Okay, address is this one. Now you can type the name of the website. So if I want to found a youtube.com, okay. So who's holding this DNS name? So Reliance is the, okay. Server unknown. Do I have to come out of this? www.youtube.com. Yeah. So let me just say this.
Type ns lookup, hit enter. Set query equals
Okay,
ns
V2
and
says
hit
set
enter.
query equal to ns.
Then type the domain name.
Set query equal to ns. Okay, now if I say youtube.com, so that's the problem. So why it's not showing Reliance? I'm using a Reliance. Yeah.
Hit enter. You will be able to see the authoritative name servers. One is master and the other is slave. Slave is the exact replica of master and is used to share the DNS server load. Now, how a computer loads a website. Suppose we type facebook.com in the web browser. Since web browser needs IP address, so it forwards the query to the computer's operating system. Operating systems are configured to forward the query to the DNS resolver. Operating system then contacts the DNS resolver. DNS resolver checks its cache whether it has the IP address of the requested website. If not, DNS query is forwarded to the root name servers. Root name server checks the extension of the website, whether it is .com, .org, .net, .in, etc. Based on the extension, the root name server provides the IP address of TLD name server to the DNS resolver. In this case, IP address of .com TLD name server is provided to the DNS resolver. DNS resolver then contacts .com TLD name server, which then provides the IP address of the authoritative .com to the DNS resolver. DNS resolver stores this information in its cache for future use and provides the IP address to the computer's operating system. Operating system then forwards it to the web browser. The web browser then contacts the Facebook server and loads the requested website, that is facebook.com. But how TLD name server knows which authoritative name server stores the IP address of the requested website? It all begins when we purchase a domain name from a registrar, for example, GoDaddy. In registrar's website, we can set the authoritative name server that domain should use. We get the details of authoritative name server when we buy a web hosting plan from companies like HostGator. Once authoritative name server details are entered in the registrar's website, registrar tells the TLD name server managing authority registry to update the TLD name server with the details of authoritative name server the user has provided. So now the server knows which. If we know the dedicated
Yeah,
IP
it is
address,
done.
the number of websites increases, which are easier to remember. More people can learn.
Yeah, so I mean, it's very simple actually. So it happens through DNS. That DNS cache will be there. It finds the IP address. It matches it. Then send the request to a web server, and then web server. Their web server technology is there. For us, it is PHP. It processes the request, send response back to a browser in the requested format. Okay. So there are various other videos also. You can have a look at it maybe later on. Okay. So I think this is what the content for today. So we understood the how does internet started, what was before internet, then what is World Wide Web, who invented this, how does client server architecture works, okay, and then how does this internet works, the entire uh, web, request response happen and so on. Okay, so thanks so much everyone for your time, and we'll meet next week and continue this. Okay, so have a great day everyone. Thank you so much. I'll stop the recording and you can break for the day. You can ask me any query. I'll be here.